In this video, we're going to talk about 4.2 Day 2, which deals with transformations of functions. In this video, we're going to identify and apply different types of transformations, both to equations of functions and points that exist on functions. We're going to look at reflections, translations, and dilations, also known as stretches and shrinks. Looking at this warm-up, we want to identify what's the differences between the items in the left column and the items in the right column. So if I look at this first row here, we need to be able to know what is the significance of having some sort of transformation like +1 that shows up outside of the function versus inside of the function. And the difference here is that one of these is going to be a horizontal transformation. That would be the +1 that occurs on the inside of your function notation. The other is going to be a vertical transformation, since that shows up on the outside of the function. In the second row, we want to compare f of x plus 3 and f of x minus 3. So you notice that both of these transformations show up on the inside of the function, so they're both going to be horizontal transformations. They both have a 3, but you'll notice that one of them is a positive 3 or +3, and the other one is adding a -3 or subtracting 3. Since both operations are addition, these are both going to be translations. The difference is the direction. So remember, horizontal transformations are always going to be opposite of what you expect. So the x minus 3 is going to move it to the right 3 units, whereas the x plus 3 is going to move it to the left. In the third row, we have two different operations. The first one is -1 times f of x. The second is f of x minus 1. Okay, so we know the adding and subtracting is going to be a translation. Since it's on the outside, I know it's a vertical translation. This is going to move my function down 1 unit. Multiplying is going to be some sort of stretch, shrink, or reflection. Whenever we multiply by -1, it's going to be a reflection. So it's going to flip the graph over one of the axes. Since this is on the outside, similar to the -1 being on the outside, it's going to be a vertical reflection. And that vertical reflection is going to flip it over the x-axis. And this might seem silly because it's vertical, so we're dealing with the y variable. But if you think about a graph of a parabola, so here we have y is equal to x squared, taking that and flipping it vertically, changing those y values by flipping it upside down, actually reflects it across the x-axis, so the opposite variable's axis. So that reflection would look like this. -1 times x squared. In each of these transformation scenarios, we're going to see some function f of x that's been transformed into g of x. So f of x is some original function. We don't know the rule. We are just going to describe how it was transformed. G of x, this is the result. This is the new function. So f of x has been transformed into g of x, and our job is going to be to describe how. And we're going to be as detailed as possible. One thing to keep in mind is high vo. I wrote that down on the last slide several times. That helps me remember which are horizontal and which are vertical transformations. All horizontal transformations are going to show up on the inside of the function. That means they're going to be directly affecting x inside the parentheses. Vertical transformations are going to occur outside of that function. They're going to be outside of the parentheses. So taking a look at this g of x scenario, there are 4 different locations where we could see an operation on this function f that's going to affect the transformation. So I'm going to first take a look at what shows up on the outside. What are my vertical transformations? And I see 2 values that show up outside. I see this a and I see d. So to recap the patterns that we found in our last lesson, if we multiply by some factor on the outside, this is going to be a vertical stretch or shrink. It's a stretch if this value is greater than 1. It is a shrink if this value is less than 1. This a value could also represent a reflection if a is negative. So if a is -2 or -1/2, any negative value, it's going to be a reflection, a vertical reflection. D represents a vertical transformation as well, since it's on the outside, but it's not a stretch or shrink. This is going to be a translation or a slide. Depending on if D is positive or negative, that's going to change the direction. So if D is positive, it's going to move it up. If D is negative, it's going to move our function down. Now onto the horizontal transformations. Horizontal transformations show up inside of our function. So these are the operations that are applied directly to x inside of the parentheses. Similar to a, this value b is being multiplied by x, so this is going to be a stretch or a shrink. However, since it's on the inside, it is a horizontal stretch or shrink. Opposite of what we would expect, if this b value is less than 1, it's going to be a stretch. If this b value is greater than 1, it's going to be a shrink. The reflection that happens horizontally will also show up in b if b is a negative value. Lastly, we have this value c, which represents a horizontal translation. We have 2 directions, left or right, like we talked about in the warm-up, is going to be opposite of what you expect. So if C is negative, this is going to be a movement to the right. If C is positive, this is going to be a movement to the left. In this table, we have a summary of those transformations, but we also have this column on the right that talks about what happens to a coordinate point. So in this column on the right, we have some point xy on the original function. This would be a point on f of x. And we're going to talk about what would happen to that point. Where would it move to if we were to apply that transformation? So we're going to look at what would happen to our new function, g of x. Where would that point move to? And how would we know the coordinates of that new point on g of x? So the first thing to look at is the types of transformations that is happening. So you can see that whenever we have a translation, so that's adding or subtracting, that's the first 4 rows here, we're going to end up adding or subtracting some value onto the coordinates. Okay? If it's a vertical translation that's going to impact the y coordinate. Just like with identifying these transformations, what we expect to happen is going to be the result. So if I'm moving my function up d units, that y coordinate is going to add d units. So if my function is moving up 3 units, I'm going to add 3 to the y value. If my function is moving down, I'm going to subtract that number of units from y coordinate. For the horizontal transformations, we are now impacting the x coordinate. So horizontal, you can see that in the new coordinate, we're impacting the x. Similarly, it's going to be opposite. So if we see a plus c plus some value in the function rule, we know that it's moving to the left, which means we're going to have to subtract. Moving a coordinate to the left makes that x coordinate smaller. If we see a minus c in the function rule, we know the opposite is happening. It's going to move to the right, which means when we find that coordinate, we're going to have to add some units. For reflections, we just need to multiply the appropriate coordinate by -1. So if it's over the x-axis, this is a vertical transformation. It's going to affect y. We're going to multiply y by -1. If it's a reflection over the y-axis, this is horizontal. We're going to multiply the x by -1. For our stretches and shrinks, if we have a vertical stretch or a horizontal stretch, we're going to look for the coordinate that it affects, and if it's horizontal, we're going to do the opposite. So for vertical, we're going to take our y coordinate and we're going to change it by the value that we see in the function. Whatever is being multiplied on the outside is the value we're going to multiply y by. If I see some multiplication on the inside, I know that's going to be horizontal, either a stretch or a shrink, and I need to do the opposite. So I'm not going to multiply by that v value, I'm going to divide. So we're going to take it one step further today. We're going to identify the type of transformation that's happening, but we're also going to use that information to change a coordinate point from the original function. So when we're given a transformation rule, the first thing that we're going to do is analyze what transformations are happening specifically to the x coordinate and the y coordinate, keeping in mind that all transformations affecting the x coordinate are going to be those that are horizontal, and the transformations that affect the y coordinate are the vertical transformations. Now, the order that we apply these transformations in is important. I like to start with horizontal transformations so that I get into the mindset that everything is going to be opposite of what I expect, even the order. So the order that we apply horizontal transformations is going to be reverse PEMDAS, which means that when I look at these different transformations on the inside of my function, horizontal transformations on the inside, I'm going to analyze and apply those transformations in the opposite order. So first, reverse PEMDAS would be add or subtract. Second, reverse PEMDAS is going to be multiply or divide. So keeping with the theme of opposite of what I expect, the first transformation that's applied is this -4. And I know that if I have a -4 on the inside, it's a translation, opposite of what I expect. This is going to move it to the right 4 units. Second is the multiply by 3 on the inside. And I know that when I multiply by 3 on the inside, the opposite is going to happen. This is going to be a horizontal shrink by a factor of 1/3. In our vertical transformations, we can follow our gut. We can follow our intuition. So the order that we apply vertical transformations is going to follow PEMDAS. So when I look at these outside values, vertical outside, I'm going to take them in PEMDAS order. So first I'm going to multiply, and second I'm going to look at this addition. Keeping with the theme of following our gut, multiplying by 5 is going to follow what we expect to happen. This is going to be a vertical stretch by a factor of 5. Second, adding 6 to the outside is going to be a translation vertically. It's going to move up my function 6 units. Now, when I think about what's happening to a point, right? These horizontal transformations, these are all going to affect x. And I know that it's going to be opposite of what I expect. So even though I see a -4 in the inside, this function is going to move to the right 4, which means x is going to increase by 4 units. Secondly, it's going to shrink by a factor of 1/3. So after that, I'm going to have to multiply it by 1/3. For my y coordinates, I'm going to follow PEMDAS order. So first, I'm going to stretch it by a factor of 5. All vertical transformations are going to affect the y coordinate. So the y value is going to be stretched or multiplied by a factor of 5. Then I need to move it up 6. So I'm going to increase it even more, this time by adding 6. So I can take any point that exists on my original function and use these transformation rules to see where that point would end up on the new function, g of x. So if I had the point 5, 8 on my original function f of x, I can take the original x coordinate, which is 5, and follow the steps that we laid out when we described those transformations. So I'm first going to take that coordinate and I'm going to add 4. That gives me 5 plus 4, or 9. We haven't finished transforming this. The second step is to take that x coordinate and multiply it by 1/3. So 9 times 1/3, 9 divided by 3 is 3. That's my final x coordinate. Now for the y coordinates, I'm taking a look at my vertical transformations. I'm going to follow them in PEMDAS order. My original y coordinate is 8, but I'm going to transform that first by multiplying it by 5. 8 times 5 is 40. I'm going to increase it further. My second transformation was to move it up 6, so my final y coordinate is going to be that 40 plus 6, or 46. So the new point that used to be located at 5, 8 is now located at 3, 46. All right, this is the point on g of x that would map out to my original point on f of x of 5, 8. All right, we're going to take a look at another one. My advice is to change the order of your transformation rule if it doesn't match what you want. And by that I mean when we looked at our function transformation rule, g of x, we put the vertical stretch or shrink first, and then we put the vertical translation last. So if I look at this function, g of x, that's given to me on this next slide, I don't see that same order. So I can use the commutative property to just move that translation to the end. I can rewrite g of x like this. Just moving that plus 14 to the end so that I can see that it's my vertical translation. So I want to identify first what's happening in this function so that I then can apply it to a transformation of a point. So my final question here is that if my original point 14, 8 exists on f of x, what would be the translated point on my new function g of x? So to get there, the first thing that we're going to look at is our x coordinates. So what's happening to our x coordinate? We're going to look for any horizontal transformations. So I see two of them, the 6x and the -4. I got to go in reverse PEMDAS order. So first I'm going to apply whatever this -4 does, and next I'm going to apply whatever this times 6 does to my point. So I know that the opposite of what I see, this x -4 on the inside is actually going to move it to the right 4. which means my x coordinate needs to add 4 if I'm moving it to the right. This 6x on the inside is going to shrink my x coordinate. It's going to shrink my function horizontally by the reciprocal, a factor of 1/6. So my x coordinate needs to get multiplied by 1/6. Okay, applying that to this point, my x coordinate originally is 14, so I'm going to take 14 plus 4, that gives me 18, and then I'm going to multiply that 18 by 1/6, giving me 3. So my final x coordinate is 3. Doing the same, but now to my y coordinate, I'm going to look for all vertical transformations. Following PEMDAS order, I'm first going to look at the multiply, second, look at the add. So first, multiplying by a -2, I know that negative is going to make it reflect, and it's going to stretch it. So what that means for the y coordinate is I'm going to multiply it by -2. Second, plus 14, since it's vertical, I'm following what I expect. This is going to move it up 14, which means for the y coordinate, I'm going to take y and I'm going to add 14. Applying that now to my original y coordinate, it started out as 8. When I multiply this by -2, I get -16. When I take -16 and I move it up by adding 14, I get my final y coordinate of -2. So my original point, 14, 8, after I apply those transformations, will be relocated. It will move or map to the point 3, -2. A couple other quick things to mention. The commutative property works for any addition, subtraction, multiplication. Commutative property is just a way of saying you can change the order of your terms if you're multiplying or adding. That 3 times 2 is the same as 2 times 3, and that 2 plus 3 is the same as 3 plus 2. It's called the commutative property. So again, if you don't see an order that you like because it doesn't match what you're used to, use the commutative property to change it. So if I look at this horizontal transformation here, I see the x is coming second, 3 minus x. If I were doing this, I would change it to -x plus 3, right? This is a +3. Flip-flop the order so that you can identify what is the transformation, or in this case, what are the transformations that are happening. Similarly, if you see a division like this function rule here is all being divided by 2, make sure that you apply that division of 2 to every single term. So feel free to rewrite this function dividing everything by 2. So g of x in this case, I would rewrite it as 4 divided by 2 minus 3 halves, 3 divided by 2, times this function f of 1 minus 2x. 4 over 2 simplifies to 2. 3 halves, I'm going to leave it as 3 halves. And then the inside, these horizontal transformations, I would flip-flop so that the x term comes first, -2x plus 1. This is also g of x. These two things are the same. It's just that by rearranging and applying that division of 2 to both terms, it might be a little bit easier to see what transformations are happening. My last piece of advice is to go slow, to take your time. There's lots of little details that we need to pay attention to. We want to be precise, and to also keep in mind that your horizontal transformations, the theme is opposite. Do the opposite of what you see and in the opposite order that you would anticipate.